Have you ever typed a prompt into an AI, gotten a really weird answer back, and just thought, what is even happening inside that thing? Well, today we're going to crack open that black box. We're going to figure out how an AI actually reads what you write. First things first, a quick little test for you. How many R's are in the word strawberry? Go ahead, take a look. Pretty simple, right? You probably got it in like half a second. Okay, but here's the crazy part. A super powerful, state-of-the-art AI, something like GPT-4, will often straight up fail this test. It might tell you there's one R or maybe three. And that failure, that tiny little mistake, it actually reveals a massive secret about how these systems think. So why does it get something so simple so wrong?
Well, the reason it gets it wrong is because of this simple but kind of mind-bending idea. The AI doesn't see words or letters like we do. Nope, it sees the world in something that's a lot more like Lego bricks. The official name for this is tokenization. So before the AI even starts to think about your prompt, it takes your text and just smashes it into these little chunks called tokens. Now, a token could be a whole word, like the, or a piece of a word, like ing, but it's almost never a single letter. And this Lego analogy you see here, it is the absolute perfect way to picture this. The AI gets a box of pre-made bricks to build with. It never, ever sees the individual little plastic bumps, the studs, that make up the bricks. To the AI, your sentence is just a string of these already assembled pieces. And this is where all the weirdness starts. So our word strawberry gets broken into tokens like stir, aw, and berry. The model literally cannot see the individual letter R inside those chunks. This also explains why don't and do not are two totally different things to an AI, why math can get wonky when a number like 124 gets split in half, and why typing in all caps is completely different from typing in lowercase. And the AI's vocabulary is just huge. I mean, imagine having a toolbox with about 100,000 of these unique little token bricks to play with. As far as the AI is concerned, that's its entire universe of language. So once your prompt is just a pile of these tokens, how on earth does the AI make sense of them? Well, that's where a really powerful idea called the attention mechanism comes into play. Now, you and I, we read from left to right one word after another. The AI, it does something completely different. It looks at every single token in your prompt all at once. This whole concept came from a famous paper called Attention is All You Need, and it's what allows the model to see how all the different parts of your sentence relate to each other instantly. So here's how that actually works. If you type, I sat by the river bank, the attention mechanism immediately draws a super strong connection between the token for bank and the token for river. It's basically telling the system, hey, it's that kind of bank, not the kind with money. It's constantly figuring out which words aren't important to which other words. But, attention isn't perfect. This chart shows this fascinating little flaw that researchers call the lost in the middle problem. Just look at this. The AI is great at remembering stuff at the beginning and the end of a long prompt, but its performance dips right in the middle. So here's a pro tip. Put your most critical instructions at the very start or the very end of your prompt. Okay, so the AI tokenizes your prompt, it uses attention to figure out what's important, and then what does it do? You've probably heard people say it's just predicting the next word. But that simple little phrase hides an incredible amount of complexity. This quote from Eliezer Yudkowsky just reframes the whole thing perfectly. I mean, think about it. To be able to consistently and correctly predict the next token in something really complex, like the answer to a physics problem, you can't just be some simple autocomplete. You have to have built some kind of internal model of how physics actually works. Predicting the next token is how it works, sure, but doing it well requires a surprisingly deep map of the world. But, and this is a really big but, there's a limit. The AI is a master of statistical patterns, not genuine understanding. It knows that the tokens for 3, plus, and 4 are very, very often followed by the token for 7. Why? Because it saw that pattern millions of times in its training data. But a big, new math problem it's never seen before, it hasn't seen that specific pattern, so it just makes a guess that sounds plausible, but is often totally wrong. It's just pattern matching. It's not actually reasoning. So, with all this technical stuff in our back pocket, let's look at all those prompting tricks you see all over the internet. Why do they actually work? Well, it's not magic. It's all about cleverly exploiting the way the AI sees the world. Let's take chain of thought prompting. I mean, just look at this jump in accuracy, from 18% all the way up to almost 80%, just by adding the magic words, let's think step by step. So what's going on here? You're basically forcing the AI to take one giant, hard prediction and turn it into a series of smaller, much easier next token predictions. Every step it writes down becomes new context that helps it predict the next step correctly.
Now, here's a fascinating little update from the world of AI research. Some new studies are suggesting that this step-by-step reasoning might just be a story the AI tells itself after it's already figured out the answer. So we're not totally sure if it's truly thinking through the problem or if it's just really good at explaining an answer it already had. The science on this is moving incredibly fast.
Okay, what about when you tell the AI you are an expert lawyer? Does that actually make it smarter? Well, this table shows you the real deal. It does not make it more factually accurate. It can't just invent knowledge it doesn't have. But what it does do is shift the probabilities. It makes the model way more likely to use legal jargon, adopt a formal tone, and structure the answer in a certain way. It changes the style, not the substance.
So, knowing all of this, we really need a better way to think about how we talk to these AIs. It's time to stop thinking of it as an all-knowing oracle and start thinking of it as a collaborator. You know, the biggest mental shift we all need to make is right here. We have to stop thinking of the AI as a search engine that just finds facts, or as a perfect oracle that knows everything. It's not either of those things. A much more accurate way to think about it is as a completion engine. It just finishes the pattern you start. Or even better, think of it as an incredibly fast, but sometimes quirky and flawed collaborator. And we have got to clear up one of the absolute biggest myths out there. The model does not learn from your conversation. Unless you're using a very specific feature, the AI is static. It's not getting smarter because you corrected it. Every single time you start a new chat, it's a completely blank slate, starting fresh from its original training syllabus. So what does this all mean for you? Really, it boils down to three things. 1. Prime. Don't just ask. Start the pattern you want the AI to finish. 2. Shape the probabilities. Use all those tricks we just talked about to guide the AI toward the kind of answer you want. And 3. Iterate. Treat it like a conversation. Tweak your prompts. It's a dialogue, not a magic spell. And that really brings us to the ultimate takeaway, which this quote just nails. Prompting isn't about finding some secret magic words. It's the skill of using language to build a context that makes the answer you want the most statistically likely thing for the AI to say next. You're not casting a spell, you're shaping a landscape of possibilities. So there you have it. You've had a peek inside the machine. You know about tokens and attention and probabilities. You're not just talking to a black box anymore. The only question left is, with this new understanding of how it actually thinks, what are you going to create with it?